All right, some of you guys like old stories about old electronics and stuff I went through. Now, in this frame, right here is a grain of wheat bulb. I'm burping. A grain of wheat bulb. It's a very small glass bead with two leads, and there's a filament in it. I'm going to turn it on. I'm not going to give it full voltage. The last one I tested, over the years, they go air. Air gets in them. So let's see if it works. Okay. The other thing that happens to them is I guess the leads get oxidized. All right, it's lighting up, right? Hopefully, let me check to make sure it's you can see it with the camera. Yeah, okay. So it's a little glass bead and it's got two leads on it. And it's what everybody used in digital displays before LEDs. All right? It doesn't have neon in it. It's strictly a filament bulb, but it's tiny. And in N gauge trains, this might be the similar uh, light bulb you use for backgrounds and displays of your houses on your N gauge layout. But this is the type of bulb we use in aircraft instruments. Now, the first thing you did when you got a box of these bulbs, and they have a lead that's about an inch long on them, you hooked them to this board that had a voltage going to it, and you had to press down these little alligator clips and put the bulbs on. They'd light up at a certain voltage, and you let them run for 3 days. And you say, why? Well, it's called burning in. So you want the filament of the bulb to see voltage for so many days. That would get rid of bulbs that prematurely fail, bulbs that have air in them, and other defects. And after the third day, you take them off. Or actually, before you took them off, you take a photometer over to them and you measure the brightness of each bulb. And you'd pull them down and put them in a little tube for them and a few extras. And those light bulbs all had the same brightness at a certain voltage. Now, those bulbs would be taken and they'd be put into these little plastic blocks that go in the bottom of the aircraft instrument. And I'm talking aircraft instrument that's in the cockpit. And there's a little drawer. It looks like a little drawer, a button. It's got a Phillips screw in the middle of it. You undo it and you pull it out, and there's two light bulbs in it. And there's one on the other side. And there's white paint all around the light bulbs inside on those blocks. And those lights, when they light up, they hit the edges of glass bezels, like prisms in the instrument. So when you turn the lighting on in the aircraft, the instrument lights up. But they're very specific lighting. They would want the numbers to be one color and the pointer to be another. Sometimes the pointer was red and the numerals were white. Sometimes it was reversed. There were some lights that came on and off to warn you, but all those bulbs had to have a certain brightness. Now, we had a thing called a light room, and you like a light room, yeah. It was a room that you could make totally dark, and the switch was real big, so you could always reach it. There was a clock in there to help orient you to what time it was, plus where you're standing. And there was a door on either side of the room, and there was two chairs sitting in the middle of this little room. And what would happen is uh, an inspector would come in, and he would sit down on one of the stools, and you'd sit on the other one, and you'd hook the unit up to a Canon plug, which would go on and twist. And it only had two wires, and that's the lighting. That goes to your power supply. And before you turn the power supply on or anything, you would look at the power supply. It was a big square box with a varactor dial, which was about 6 inches across. You would turn that dial all the way down, and you'd throw the switch on the lowest scale. The instruments for aircraft, they use 400 cycle, and it was like 24 to 28 volts. And You would turn it on, and you would turn the dial up, and the meter was lit, and you'd read the voltage at which the instrument came up and was of equal lighting. That was the bottom number. Then the top number, and you go between the range of the bottom and the top, and the inspector would watch the display of the instrument that it stayed even brightness, because it has 4 light bulbs. It's got all kinds of glass that's like I almost say prisms, but basically, yeah, they call them bezels, but they were the bezel of the unit maybe had 2 or 3 of these glasses that would disperse the light. They would get their light on their edge, and then they would disperse it on the inside. You could probably buy an aircraft instrument surplus somewhere on the internet and take one apart and get to, see the synchro inside. There was a synchro receiver way back, and then later on they used electronics. But up under the wing of the plane, there was a synchro transmitter, and in the instrument was a synchro receiver. And they were 3-phase, 400 cycle, and when you would turn the synchro under on the wing, down inside the plane, the synchro receiver would move to it. It's just 3 phases and a shaft that moves with an armature that's got 3 phases. Go look on synchro receivers, synchro transmitters. You'll understand how they work. Very simple stuff. The hardest part of the instrument was getting the lighting correct. And you had this sparker. It was a high voltage unit. And when you're in the light room with the lights out, with just the instrument lit, the inspector would look inside the instrument and look for specks of dust. And if it was too big, it was deemed a moon rock. And that meant the unit had to be taken totally apart. Now, there was a way with the sparker, it's a high voltage sparker, you could move the speck of dust statically. It's behind the glass, but you could move it off to the side, and the inspector would let the instrument pass. I just want to tell you some of this stuff. It's very complicated, simple things. So a lot of times you get the instrument in, and you rebuild the synchro receiver, make sure it was up to spec, put it all back together, calibrate it, and you never touch the light bulbs. They were good for so many 100 hours, 100,000 hours. But when you did, I knew all the steps. I worked with the girls down in Fort Lauderdale in Thomas Edison Labs building. It was called, Edison Avionics. I sat with each girl, and I learned the steps of each job. Now, there was a guy who was supposed to be working with me. He spent his time up sitting with the boss, brown-nosing him. I used to call him Clown Face. He had this he had a clown face. And he didn't have to do any of the jobs. We got back to West Orange, and the boss, I was doing something for somebody else, and the boss gave him something to fix. He went over and ordered brand new ones from stock. And that set up an emergency draw, went over to production. They came up to me. I'm like, where is this coming from? Found out it was him. He didn't know how to fix the instruments. He kept telling me he knew what he was doing. He didn't know what he was doing. He never sat with any of the girls. I did. Every day, I sat with a different girl, and they'd show you what you're supposed to do, how it's supposed to pass. Some of the tricks, like you don't put brand new light bulbs in an instrument. You don't solder them in. You have to age them, burn them in. Then you checked with a light meter, and you set aside. You just didn't pick 4 light bulbs. You picked a couple extra. You put them in this tube thing. You marked it, and that went with the instrument. And then when you're putting the instrument together, you're in the light room. You might have to add some white paint in one of the light bulb boxes, or whatever you want to call them, assemblies. And to get the light, you want the instrument to be lit evenly at a certain low voltage. And then as voltage come up, you don't want that instrument. You want that instrument to get brighter evenly, and that's how good the instrument is made. You try to do that with regular light bulbs. You try to do that with something you build, and you're not going to be able to achieve it. Now, of course, everything's LED now, but I'm going to tell you, back in those days, they had, and I can't turn this thing brighter because the other one burned down I burned my finger on it. I was like, why do I smell something burning? Yeah, this one's doing better. But that's what we had in the instruments, 4 of those. And they burn a lot of hours because the company that sold you the light bulbs burned them in for so many days. And then they ship them. Now shipping, a filament can break. It could just be the light bulb decides to take air in through the leads where it's, I should know, sealed. I should know that. I did light bulbs and mercury switches. Well, anyway, I wanted to show you this because this is how it was done in the old days. And there were a lot of steps. That's why when they went to LEDs, now picture this. We're getting ready to sell to Litton Industries. Our engineers have already built instruments that use LEDs. And the FAA wouldn't accept them. We can't have that. The instrument has to hold the last reading if the power fails. The power fails in the airplane. Having the last reading on the instruments is not going to do you any good. It's like at one point, we did helicopter brake pressure meters, Thomas Edison ones. And the inspector comes in, and he says, when I turn the instrument upside down, the meter doesn't read correctly. I said, the helicopters don't fly upside down. He's looking at me. He says, well, that meter has to work correctly. I said, show me in the manual. Show me. They put me on this job to straighten this out. And how I straightened it out, I said, where's your boss? I want to talk to your boss. Brought him down, told him all. He goes, he turns to the guy and goes, what are you doing? He says, it's not in the manual. This is a helicopter that's brake pressure is when you're on the ground. When you're flying, you're not worried about brake pressure. He just told the guy, he said, this instrument has to read correctly when the helicopter's on the ground. And it's rolling along and you want to stop it. It's letting you know you have enough pressure. And that was it. But man, my boss, I told you, Goldberg, he went running. The other guy went running. I just said, let me see your boss. Bring your boss down here. I want him to tell me that after we made the things, we made those instruments for, but the helicopter was like, say, 1952. They really perfected them for the Korean War. So that was 72. So that's 20 years that Thomas Edison Labs, made a brake pressure meter, and no one ever put it upside down. And this guy, we had engineers that would just, and inspectors that just would invent the test. It's in the book. You have to go by the book. Never once did it tell you, let me shut this off. Never once did it tell you to put the meter upside down and see if it reads correctly. And then we had inspectors that would come in and hook the instrument up, the cannon plug on the back. It plugs into the back. You turn it so it locks, or you screw it until it locks. And they flip the switch on. They blow all the light bulbs out in the unit and go, oops, oops. So you're in this light room with the guy, and it would be very easy to lose your temper and kill him. Okay? It's that simple. Because you're talking 8 hours to go redo those blocks with the white paint and the whole thing. And you have to take the instrument apart. In some cases, the light bulbs are inside. They're not in light blocks. Oh, and the instrument's sealed. It's solder sealed. The back lid on the instrument is solder sealed. In later years, they used this metal tape that looks like the tape you tape your air conditioning in with. It's double sticky or a single sticky, and it also looked like years ago juice cans. You used to open a juice can up, like a V8. Used to pull this little. It wasn't a tab. It was a piece of aluminum tape, and you peel that off the opening, and you drink your V8. And that's what it was. And that was the easier machines units. And a lot of units, you had to have a desiccant donut inside, and the desiccant donut would have to be put in an oven, heated up, vacuum pump, and that would pump all the moisture out of the vacuum, out of the oven, and then that desiccant gel donut would dry out because it's being warmed, and there is no atmosphere. And then before you solder the unit apart, that little desiccant donut went in like a little grid in the back, a little miniature chicken wire holder. And then you immediately close the unit up, solder seal it closed, or put this tape around it. Then you put it in the oven and warm it up and draw the air out. Then you backfill the air, the vacuum, with nitrogen, and then you put this little screw into the hole or a piece of that aluminum tape over a thing with a date on it. Everything had dates all over. It was Julian date. It wasn't a regular date. It was Julian. And I had a guy I worked with. He always knew what the Julian date was. My handwriting is terrible, but when it comes to printing and writing with Indian ink and the pen, it was a stick pen. That's what you had to use. And you would draw the date on a piece of aluminum sticky. It was like a piece of tape on the back of the instrument and had a line. It would say date. And you had to write the Julian date. And everybody handed to me the units to put the date on them. Because my handwriting, I could write the numbers within that space and the whole thing. I learned all these different skills and Goldbrick threw me under the bus. In order to keep one of his buddies from Bendix, he let me and Pete go ahead of time. And then they immediately had to hire somebody to fill my position, and they didn't call me back because Goldbrick didn't want me back. He threw me under the bus. I know the term now. There's a lot of authoritarianism guys throw their employees under the bus when they make a mistake. And I went through all that. I know all about these things now. But I just wanted to show you that little bead. You know, it's called a grain of wheat bulb. And I tried one before to set this up to show you. And I started smelling something burning. What it was is the bulb, the envelope had taken on air. And as I'm turning it up, the filament went black. And I'm like, wait a minute, I hardly got up there. Now this one here, okay, this is supposed to be 12 volt. Yeah, I'd say that bag works best at 5. But it's just a little glass bead with 2 leads. But it's not an LED. And that's what we used to use in the old days. You know, hey, Grandpa, is that what you used in the olden days? Yep, that's what we used. I think that's it. All right, that's it.